Good morning, everyone. We are going to continue with applications of estimating, point estimate for population proportion. Let's read this one in here. This is how to use the stat crunch and how to determine the sample size with a given confidence interval for a population proportion. Let's read that one and see how we can use this to answer this particular problem, all right? Obi, let's read the number one. The problem first. Let's read the problem first, thank you.
An economist wants to know if...
Sorry for that. Here it is. All right, thank you.
All right. An economist wants to know if the proportion of the U.S. population who commutes to work via carpooling is on the rise. What size sample should be obtained if the economist wants an estimate within 2 percentage points of the true proportion with 90% confidence? If A, the economist uses the 2009 estimate of 10% obtained from the American Community Survey, or B, the economist does not use any prior estimate.
Thank you. Okay, so as we may notice in here, it is already said that it is within 2 percentage points. So which means that these 2 percentage points in here is basically what we call our margin of error. Okay, so once again, this will be our margin of error simply because that's the number that you add or subtract to the proportion estimate to get that low bound and high bound for such. And this 10% in here is basically what we call our P. All right, so that's our population proportion that is already given. Now, what is our 90% in here? What do you call that 90%? Robbie, what do you think is this 90% given for such? That's the confidence level, right? So very good. So we are already given the following. The 10%, that is the population proportion. The 2%, 2 percentage points, which is what we call the estimate, right? So that means that's the high and the low, okay? And the 90% confidence interval is the allotment for such. So if we will try to illustrate this, so if this will be our normal plot or normal distribution, this is our P, which is how much? 10%, okay? You can put it as 0.10 as well, okay? Now, since the margin of error is 2 percentage points, and that means from 10, you what? Add 2, right? So what's 10 plus 2? 12%, very good. So this is 12%, that's the high bound. Okay, or we can call it 0.12. And this is the low bound. What do you think is the low bound? What do you do with a 10% and 2 percentage points margin of error to get the low bound? Subtract, very good. So it's 10 minus 2? 8%, very good. So this is now 8%, or basically in decimal 0.08. Okay, so I'm putting in here either their percentage points or the proportion. Since this is proportion, we're going to use those ratios instead. Okay, so basically whatever percentage points you're getting, what do? Just divide it by 100%. And again, what is our confidence level? We said this one should be at a 90% confidence level. So what do we need? We need to get this in here. How much do you think will be our sample size to achieve that result, right? So how big of a sample size should we need to achieve that result? Okay, let's read this one. This one is our stat crunch on how to select how to determine the sample size with a given data in there, okay? So let's read this one and see how we can use StatCrunch for such. Go ahead, Obi, let's read the first step. Select.
The determining sample size?
Yes, thank you.
Select stat, then proportion stats, then one sample, and then width/sample size.
Thank you. All right, so let's do that one. Let's go get our StatCrunch to use that method, okay? So stat, proportion stats, one sample with sample size. Let's do it. Let's go here, okay? So let's just click any of these questions. Just don't mind the questions, guys. We're just basically gonna work on one of them anyways. Again, don't mind the question. I'm just gonna click on the stat crunch in here to use this stat crunch. Here it is. So what do? It says we go to stat, and then what do? We go to proportion stats. So because this is population proportion, okay? Here we go. Let me just erase everything in here and focus on that. So again, stat, proportion stats. How many samples? One sample only, okay? And we want to know the sample size with the width. By the way, the width in there is basically the margin of error that we're talking about, okay? So once again, stat, proportion stats. Again, because this is population proportion, we only have one sample and we want to know the sample size given the width, okay? Given the margin of error, okay? By the way, the width in here in StatCrunch is the margin of error, by the way. Let's click on that and put it in here. So what's our confidence interval a while ago? It says how much? 90%. Very good. What's our target proportion? We said a while ago, I think it says 10%, right? 0.1. So instead of 10%, I'm going to put the proportion. 10% divided by 100 is 0.1. Okay? Width. The width is the margin of error. So what's the margin of error? Well, 2 on the left. Well, 2 going to the high bound. 2 going to the low bound. So that means your margin of error is how much? 4. Very good. All right. So whatever your what you call a while ago, what you add and subtract a while ago from the point estimate, that will be your margin of error times 2. Okay. Again, the margin of error is times 2 of that. So width is 0.4. Okay. 4%. Okay. So again, we want the sample size. Let's click in here and see what we're gonna get out of it. Okay, so as we may notice in here, with a confidence level of 0.9 and a target proportion of what's this? 10%. With a width of 4%, our sample size is 10. Right? So let's see. Did we get a sample size of 10 for such? Okay, let's see here. Did we get it right? Let's see. Okay, so enter the confidence level. For the target proportion P hat, enter 0.5 if there are no prior estimate of P. The width is the difference between the lower bound and the upper bound. Therefore, the width is 2 times the margin of error. So in here, the margin of error is 4. And the confidence interval is 0.9. Did we put it right in there? Let's go back in here, right? Okay. Here it is. Confidence level, confidence interval, 90%, that's 0.9, right? Target proportion is 10%, right? Okay. In here, we said, oh, okay, you know what? It should say 4%. I think I put in 40%, right? 4%, so 0.04, right? Okay, I think I missed one more 0 in there. And let's click on the sample size. Okay, there we go. Okay, so I just forgot the other 0 in there for the 4%, right? Because a while ago it should have been 0.04, but I put in 0.4, so it make it 40%. So, you know, be careful with the decimal points as well. So again, 90% confidence interval. The target proportion is 10%. In proportion is 0.10. The width is 2%. Well, 4% because it's double the one that you added and subtracted. And it gave you the sample size of 609. Any questions with what we did, guys? Any questions?
Is that the number you plugged in for width? Or no?
The width, yes, that's a number that we plugged in for width. So we plug in the width in here, 0.04. And as you may notice, that's a good question, Obi. Because look at that. And a good question because Obi said, why is it Mr. Deal? You put in 0.04 and then it changed after that, right?
Yeah.
Because it estimates it a little bit as well. So it's gonna be rounded off something, right? So yes, I did put in 0.04, but if I click in there, it's gonna give you a 0.039999, which approximates 4% anyways, okay? So again, it might change a little bit here and there, but still you're gonna get the sample size. You know why? Because it wants the sample size to be what? An integer values. That's why it's trying to play with the width that you put in, putting it the nearest to 4%, with the sample size being an integer value instead. Because again, when you say sample size, it should be what? A whole number. Questions? Questions, guys? Hey, what's up?
How did you get to that graph again?
Okay, so good question. So what do we do again? Let's review. Where do we go? Guys, go to stat. Very good. Next,
Proportion.
proportion, because we are doing proportion. How many samples are there? One sample. What are we getting? Sample size given the width or the margin of error. So we're gonna click on the sample size given the width or the margin of error. And yes, we're gonna go here and play with those in here depending on the given. Our given a while ago, 90% confidence interval, target proportion 10%, and the width is double the added and subtracted from your point estimate of proportion. Questions, questions, questions. Now, what we're gonna do is to work some more on some actual problems from our Pearson. All right, so here it is. Let's work on this one, question number 2, and let's see this question number 2, how we can work on this one. Okay, so let's see, question number 2.
Question number 2.
All right, let's read this one in here and see how we can work on this question number 2. All right, Johnny, let's go ahead, read this one first.
Determine the point estimate of the population proportion, the margin of error, the following confidence interval, and the number of individuals in the sample. Specify characteristics 8 for the sample size population.
Provided, very good, right? So the given are the following. Lower bound is 0.676. Upper bound is 0.884. And what's 1500? Sample size, right? So that's how big the sample size is. So let's illustrate first. How does it look like? So again, you might be asking, Mr. Deal, why are we always considering a normal distribution for such, even if it doesn't say it's a normal distribution? Why, guys? Because
Sample size greater than 30.
very good. The sample size is big enough according to what? Central limit theorem, right? If the sample size is big enough, it doesn't matter. Regardless of the population shape, your sample distribution should always be a normal kind of distribution. Okay? Right. So please keep that in mind. Even if it doesn't say normal distribution, we can always assume normal distribution as long as your sample size is a big number. Okay? How big? 30 up. Okay? So with that being said, what are in here? The low and the high will be the following. What does it say? 0.676. Oops. And the other one in here is 0.884 proportion, right? Okay, so first question. How do we get the point estimate, guys? The point estimate is basically the what? The number at the middle of the low and the high. Okay, so in short, if you're given the low and the high, you want to get the point estimate. How do you get that? Anyone? Recall your measure of central tendency? Add and divide by 2. Very good, right? That's correct. Get the average of those two numbers. In short, that is the mean, right? Or the average. Okay, so that's what we do. What's that going to be? 0.676 plus 0.884 divided by 2. Once again, that also confirms that this one is a symmetric normal distribution, right? Because whatever happens to the right, to the high, and to the low, you split into 2, you're going to get the point estimate. So, what's that going to be? 0.676 plus, what's this? 0.884 divided by 2. How much did you get? 0.70. So we know that this one now is 0.78. Again, always notice that point estimate is the midpoint of the high and low bounds. Okay, in short, that's the average, that's the mean. Okay, next one. How do we get the margin of error? Okay, so how do we get the margin of error in here? So here it is. We're also gonna do the what's this? The StatCrunch for such. Did we see anything from StatCrunch that mentions margin of error? Let's go back in there and see from there. Okay. Okay. Let's go back in here. Oh wait, later. We're gonna do that one for the confidence interval, okay? But for the margin of error, let's go back in there and see first how to get, the margin of error. Once again, okay. Here it is, okay. So the margin of error is like what? How far is the point estimate from either the high or the low bound, okay? So when you say the margin of error is this, okay. Here it is. That's the margin of error, right? How far is the point estimate from either high or low, right? That's why if you double that, okay, that will be the case. So in this case, what is our margin of error? So what do we do? With 0.884 and 0.78, subtract them, right? Just get the distance between those two. So what do we have? 0.884 minus 0.78. What did we get? 0.104. So this one in here is 0.104, and we can assume that this one is also 0.104. Since this is normal distribution, then we know that this is symmetric around the point estimate. So that verifies our margin of error. Questions? Questions, guys, with what we did? Got it. Okay, the next one. Let's read this one in here. Letter C. Okay. Did we get the same answer?
So for B, you subtracted the upper bound, you subtracted the
the
lower
upper bound from the point estimate. So 0.884 minus 0.78, that's 0.104, right? Also the same. Either you do that one from the high bound, you can also do that one from the low bound, because this one minus down is 0.104. Again, because that is symmetric, that is normal distribution based on, what do we say? Central limit theorem, okay? Next one. How many individuals in the sample were having that specified characteristic? So, when it says 0.78, so we are assuming that 78% of that 1500 will have that characteristic. Get what I mean? Okay, so let's see. Is that actually 1170? When we say, again, the point estimate is 0.78. So that means 78% of the sample size will have that characteristic. And what is that? Well, it doesn't say what this characteristic is, but let's see. What's that gonna be? Let's verify in there. So this one should be equal to what? 78%, okay, 78%, that's a point estimate of the sample size. And how big is the sample size? 1500. Okay, let's see. What is 78% of 1500? Did you get the same answer? Right? 1,107. Questions with what we did for number 2. Okay. All right. So hopefully that
pen is not having a good day. Scary, huh?
It's scary, right?
Yeah. You gonna hold it?
Okay, anyway, going back. Let us work on one last problem in here. and see how we can work on this one, okay? Let's read the numbers 15 to 20 and see how we can work on this, okay? All right, Brett, let's read this one first. What do we do with 15 to 20?
Construct the confidence intervals of the population proportion at a given level of confidence.
Thank you. So this one, we're gonna create a confidence interval, meaning what is the low bound, what is the high bound, okay? Given X is 20, N is 500, and 99% confidence level. So in here, basically we're gonna use a calculator work for such, and let's read how do we do our calculator work for this, okay? Let's read this one in here and see how we can use this. How to create a confidence interval for a population proportion, okay? Let's read this one. JC, go ahead. Yeah. If you have
Which one is it?
confidence interval, StatCrunch. Okay. It's in your thing. Anyone who saw it on your Mason, go ahead, please. Yeah.
If you have raw data, enter the raw data into the spreadsheet.
Okay, which we don't. We don't have a raw data, but we have a summary of the data, okay? Because we already have the proportion, the X and the N, and the confidence interval, right? Okay. Let's read step number 2. All right. JC, were you able to see it? Number 2. All right. Thank you.
Which paper is it? 'Cause I can't see that.
Okay. Emma, go ahead, please. Number 9.1, right? 9.1. Go ahead. The second page. Thank you.
Number 2. You said?
Yes.
Select stat, then proportion stats, then one sample, and then choose either with data or with summary.
So again, we're gonna choose the with summary, right? Why? Because we don't have the data set, but we do have the summary for such, okay? Able to see it in there? The second page of 9.1? Able to follow it in there, guys? 9.1, second page. Got it? Everyone saw it? Is it the second page? I think it is, right? So, let's do this one. Let's do number 17. Typically, number 17, when you say 99% confidence interval or confidence level, you typically use that one for like a really powerful research, like say a medical research. You want it to be having a high percentage of confidence, all right? So, let's do that one. X 120, N equals 500. And 99% confidence level. Okay, that's really high. Okay, so that means in here, if you have X is 120, that means those are the number of people or participants in the sample having that characteristic. And N is the sample size. What can you say from here? That your P hat is equal to how much? What do you do with these two to get the P hat, guys? Divided. Very good, right? So what's that? 120 over 500, right? Because it says in here that out of 500, 120 of them will have that characteristic. So what's the proportion then? On your calculator?
124.
Thank you. 0.24. Or we can say that 24% of those 500 individuals have that characteristic. Okay, whatever that characteristic is. But we're going to see what the margin of error is and the confidence data in here. So here it is. Let's click on, again, either any of them. Let's go to what? StatCrunch. After going to StatCrunch, where do we go? Stats. Proportion. Stats. How many samples? 1 sample. And we don't want sample size. We do have a sample size. This time we want a what? Summary, right? Because we have a summary, right? So how many successes are there?
120.
120, right? Those that have the characteristic. Okay, that's your X. How many observations in there? In short, the sample size. How big is the sample size? 500. Very good. Okay. Now in here, I'm not gonna do this hypothesis test. That's a different unit. I'm gonna click on the confidence interval, okay? And how much is your level of confidence interval? It says 99%. Get it? Okay. Now in here, leave this one at standard. Okay, at standard. And there we go. You can click on this confidence interval plot if you want to see that one. And let's click on compute. Okay. Once again, number of successes X. N is the sample size, number of observations. Click on confidence interval, put it in there. Make sure that it's standard. You can click this one as an option or not, and then click on compute. All right, there it is. Okay, so what's your lower limit? So if we draw it in here, it does look like what? So here it is. What's your population proportion? 0.24. So if this is 0.24, what's the high bound? Upper limit? 0.289.
Plus, yeah.
Okay, 0.289. Did it say, by the way, be careful the decimal places, right? Did it say how many decimal places? Okay, I would say just 0.289. All right, that'll be fine. Or 0.29 if that's 2 decimal places. What's the low bound? 0.191. Okay, so in here I'm gonna put 0.19. Okay, so there it is. That will be our high bound, higher bound, and lower bound for such. Also, it would say in here total sample size 500. Count how many have the characteristic 120 with a proportion 0.24, which we already got a while ago, anyways, right? So that confirms that is our what? P hat. Okay. Questions, guys? What do you think is the margin of error for this? What do you do? When you subtract these two together, you're gonna go get the margin of error. Okay, so what do you think is the margin of error for this one? If you look in here, what do you think is the margin of error? 0.289 minus 0.24. Again, this is not needed. However, if it's asked, then at least you know this is approximately 0.05. Okay, so it has a 5% margin of error. Okay, questions with what we did? So again, this is mostly StatCrunch calculator work. So as long as you know how to do that one in a StatCrunch, then you would get the answer. Once again, what do? You go to stats. Next. Where do we go? Proportion. Very good. Next. One sample. Very good. Next. Summary. Okay. Typically for this, we have the with summary because we already are given the X and the N. Okay. But if you are given a whole list of like values, then you're gonna click on that with data. Okay. Also, this with sample size. Once again, we use that one if you need a sample size and you're given the margin of error instead. Okay, so there are 2 options for such. With summary, if you want to get the confidence interval, sample size with sample size, if you need the sample size given a margin of error. Questions with what we did? All right. So that summarizes our what's this? Point estimate of population proportion. All right, thank you.